somewhere out in the dark, far beyond the reach of any window or any night you have ever stood beneath. There are clouds so vast and so unhurried that the word cloud barely does them justice. They are not the soft gray heaps that gather over an autumn afternoon, not the thin wisps that trail behind a mountain at dusk. These are clouds made of gas and dust, of hydrogen and helium and the finest imaginable grains of something almost like soot. And they drift through the galaxy the way a thought drifts through a mind that is very nearly asleep. Slowly, without urgency, without any particular destination in mind. We call them nebulae, a word that comes from the Latin for mist. And mist is perhaps the closest thing on Earth that gives you any feeling for them. Though even the thickest morning mist in a valley is dense beyond comparison to these great wandering clouds. If you could somehow step inside one of these nebulae, and imagine just for a moment that you would not feel it against your skin. You would not see your breath fog in it. The material is so thinly spread, so gently distributed across such unimaginable distances, that you might float through thousands of miles of it and notice nothing at all. And yet, gathered together across the span of light years, these clouds contain everything that stars will ever need to begin. It is a beginning so slow and so quiet that the word beginning almost feels too sharp for it. There is no moment of decision, no clear line between before and after. There is only the cloud, drifting and then over millions of years. The cloud beginning very, very gently. The train. Imagine the color of it, if you could see it from a great distance. Some of these clouds glow faintly, lit from within by young stars already burning nearby. And they bloom in colors that painters have spent lifetimes trying to find words for. Soft roses and dusty purples, pale golds and the most delicate blues. All of it hazy at the edges, all of it dissolving into the dark the way watercolor dissolves at the edge of a wet page. Other clouds are dark, so thick with dust that they block the light of everything behind them, and they appear as absences in the sky, as shapes of nothing, as silhouettes of something you cannot quite see. Both kinds are beautiful, both kinds are patient. The gas inside these clouds is mostly hydrogen, the simplest element there is, the first thing the universe made in its earliest moments, and it has been drifting in one form or another ever since. There is something quietly wonderful about that. The idea that the material floating in these vast dark clouds is, in a sense, very old. Older than the sun, older than the earth. Older than almost anything you could name. It has been part of other things before. Perhaps it has been part of other stars that lived their long lives and breathed their material back out into the galaxy. And now it drifts again, waiting in no particular hurry. Alongside the hydrogen and helium are traces of other things. Molecules of water ice, frozen onto tiny grains of dust so small that thousands of them could sit side by side across the width of a human hair. There are simple organic molecules, the building blocks of things far more complicated. All of it suspended in the cold and the quiet. The temperature inside these clouds is extraordinarily low, colder than anything we experience on Earth, colder than the coldest night on the coldest continent. And in that cold, everything moves very slowly, very gently, like a room where everyone has already fallen asleep. And it is in that cold, In that dark, in that patient and unhurried quiet, that something begins to happen. The cloud, you see, is not perfectly uniform. If you could look closely enough, and we are talking about a kind of looking that requires not eyes but mathematics, not windows but radio telescopes listening to the faintest signals across space, you would find that the cloud is slightly thicker in some places than others. There are regions where the gas and dust have gathered just a little more closely together, where the material is just a little denser, a little heavier. These regions are not dramatic. They do not announce themselves. They are simply slightly fuller than the space around them. The way a river is slightly deeper in certain places without any visible reason. The way a field of snow is slightly higher in one corner where the wind has been. But gravity, which is patient in ways that even these clouds would recognize, takes notice. Gravity is perhaps the gentlest force in the universe, in the sense that it works so quietly and over such long stretches of time that you would never feel it pulling on any given moment. But it is also the most persistent. It does not stop, it does not rest. And so, in the regions of the cloud, where the material has gathered just a little more thickly, gravity begins to draw more material inward. Very slowly, over hundreds of thousands of years. The denser region becomes denser still. And as it becomes denser, its gravity grows just slightly stronger. And so it draws in a little more. And it becomes denser again. This process has a name: gravitational collapse, but collapse is perhaps too dramatic a word for something that unfolds across timescales so immense. It is less like a collapse and more like a settling. Like the way a deep, comfortable chair seems to hold you more completely the longer you sit in it. Like the way a warm room gradually becomes warmer as the evening goes on and the fire finds its rhythm. The cloud settles inward, region by region. Over millions of years, and in the settling, something new begins to form. At the heart of a collapsing region, where the material has gathered most thickly, a core begins to take shape. It is still made of gas and dust, still cold and dark and quiet. But it is growing, it is accumulating. The gas and dust falling inward from the surrounding cloud joins it. Layer upon layer, the way snow accumulates on a quiet night. Not in any rush, not with any sound. Just steadily, gently adding to what is already there. And as the core grows, something else begins to happen. The material falling inward carries energy with it. And as it compresses, that energy has nowhere to go. And so it becomes heat. Very gradually, over a very long time, the core begins to warm. Not yet to the temperatures of a true star. Those are still far in the future, still millions of years away, but warm enough to begin to glow, faintly in wavelengths of light that our eyes cannot see. In the infrared, the way a stone holds the warmth of an afternoon long after the sun has set. This early warming, slowly brightening object is called a protostar, and it is one of the most quietly beautiful things in the universe. It is not yet a star. It has not yet begun the great sustained burning that will define the rest of its life. It is something more like a promise, or a beginning that has decided it would like to continue. It is wrapped in the remaining gas and dust of the cloud from which it formed, and that material swirls around it in a broad, Flat disk, the way cream swirls in a slow cup of coffee. The way leaves gather in circles on the surface of a still pond. That disk in time may become planets. But that is a story for another night. For now, the protostar simply glows and gathers and grows. And the cloud around it continues its patient work of feeding it, adding to it, building it up over hundreds of thousands of years. There is no hurry. There has never been any hurry in any of this. The universe has time in quantities we cannot truly imagine. And it spends that time without anxiety, without urgency, without any sense that things need to move faster than they are already moving. If you could somehow stand very far away at a safe and comfortable distance and watch a nebula over millions of years, the way you might watch a time lapse of a garden growing over a single summer, you would see the clouds slowly brighten in certain places, slowly draw inward, slowly concentrate its light. You would see the hazy glow of the surrounding gas lit from within as the protostar at its center warmed. You would see the disk of material swirling around it, catching the light, scattering it in soft and diffuse ways. And gradually, over a span of time that dwarfs everything human civilization has ever done or thought or built, you would see the protostar growing brighter and warmer and more itself. The smell of it, if smell were possible in space, and it is not, of course, but if it were, would be something like the smell of cold stone, or of rain before it falls, or of the air at the very top of a mountain where it is so thin and so clean that it barely feels like air at all. There are molecules in these clouds that, if you could somehow encounter them in a breathable environment, would smell faintly of raspberries and rum, because the same simple organic molecules that give those things their scent exist in the spaces between stars. The universe is, in its own way, a place of unexpected warmth and sweetness, even in its coldest and most distant corners. And all of this, the drifting cloud, the patient gravity, the slowly warming core, the swirling disk of future worlds, all of this is happening right now, in nebulae scattered across our galaxy and across every galaxy we have ever seen. At this very moment, while you rest, while your breathing slows and the room around you settles into its nighttime quiet, somewhere in the Milky Way, a cloud of gas and dust is beginning, very gently, to gather itself together. Somewhere a protostar is warming, adding to itself, taking its first slow steps toward the long and steady burning life of a true star. It will not be rushed. It does not need to be. It has millions of years ahead of it before it reaches the moment of ignition, before the pressure and temperature at its heart become great enough to begin the fusion that will sustain it for billions of years to come. For now, it is content. If content is a word we can use for something so vast and so simple, to simply grow and warm and wait. There is something very restful in that, if you let yourself feel it. The idea that the universe is full of things that are in no hurry, that the greatest and most luminous objects in existence began as something almost impossibly quiet and slow and patient. That light itself, the light of stars, the light that has crossed billions of miles to reach your window on a clear night, began in darkness, in cold, in a cloud so thin and so still that it barely existed at all. The clouds where stars begin are, in their own way, the most peaceful places in the universe. Nothing moves quickly there, nothing announces itself. The change, when it comes so gradually that there is no single moment you could point to and say, "There, that is when it began." It simply begins the way sleep begins, the way a dream begins. Not with a sharp edge, but with a softening, a settling, a slow and gentle gathering of things toward their center. And in that center, something new is always forming. Something that will one day burn brightly enough to warm a planet, to drive the chemistry of oceans, to light the faces of creatures who will look up at the night sky and wonder where it all came from. But that is still far away. That warmth, that light, that long and luminous life, all of that is still deep in the future of the protostar curled at the heart of its cloud, still surrounded by the soft and dusty dark from which it came. For now, it is enough to rest in the quiet of the cloud, to let the darkness be soft rather than empty, to feel the slowness of it, the patience of it, the way that even the most extraordinary things in the universe begin with nothing more dramatic than a gentle gathering, a slow settling inward, a warmth that builds so gradually you would never notice it happening if you were not paying very close attention over a very, very long time. The cloud drifts, the core grows. The protostar warms at the heart of its dark cocoon, adding to itself grain by grain and molecule by molecule, in no hurry at all, surrounded by the same ancient hydrogen that has been part of the universe since its earliest moments, patient and quiet and full of the most unhurried kind of potential. And somewhere nearby, in the same great cloud, other regions are beginning their own slow gathering. Other cores are forming, other protostars are warming in the dark. Stars are rarely born alone. They tend to form in clusters, in families, in loose and drifting groups that will spend millions of years together before the gentle forces of the galaxy gradually carry them apart. But that, too, is a story for later, for another quiet chapter in the long and unhurried life of a star. For now, we rest here, in the cloud, in the cold and the dark and the patient quiet, in the place where everything begins, slowly, without announcement, without urgency, in the most gentle and unhurried way imaginable. And so it begins, though begin is perhaps too sharp a word for something so gradual, so unhurried, so entirely without the quality of suddenness. What happens next in that deep and quiet place happens the way a thought forms in the moment just before waking, the way warmth returns to cold fingers held near a gentle flame. Not all at once, not with any particular announcement, but slowly, the way everything real and lasting tends to happen. The cloud is still there, that vast soft gathering of hydrogen and helium and the faintest traces of other things. Dust motes almost too small to imagine. Carbon and silicon and iron worn down to the finest possible grain. Drifting in the dark the way flour drifts when you tap a sieve very gently over a bowl. It has been there for a long time. Time out here is not the kind of time we feel in our bodies. The kind that pulls at us when we are tired. The kind that stretches in the afternoon when the light is low and golden and the house is quiet. Out here, time is something else entirely. Something patient, something that does not mind waiting. And in that waiting, something almost imperceptible is already happening. The cloud, you see, is not perfectly still. Nothing in the universe is ever perfectly still, though the universe comes closer to stillness than we do. and it comes closest of all out here in the deep between things. But even here there are small movements. The faintest of pressures, a slow and barely measurable drawing together. Gravity is at work, and gravity is perhaps the most unhurried force there is. It does not rush, it does not insist. It simply pulls very gently. The way a long piece of music pulls you forward through its phrases without your quite noticing that you have leaned in. The cloud begins to gather itself toward its own center. Imagine, if you like, the way fog on a cool morning seems to thicken near the ground. The way it pools in the low places between hills, soft and gray and faintly luminous. Something like that is happening here, though on a scale that makes the word vast seem almost quaint. The outer edges of the cloud are still thin and pale and barely there. Wisps and tendrils of gas so diffuse that the space between one atom and the next is enormous. A loneliness of scale that is almost peaceful to contemplate. But toward the center, things are beginning, very slowly, to press together. It takes millions of years. That is worth sitting with for a moment. That softness of duration, millions of years of slow gathering, of patient compression, of gas and dust finding its way inward by the most gradual and unhurried route. There is no hurry, there is no reason for hurry. The universe is not watching the clock. The universe, in a sense, is the clock, and it keeps its own time entirely. As the material at the center draws together, something begins to change. Pressure builds. The way pressure builds in bread dough when you fold it. The way it builds in the earth beneath deep snow. Gentle and cumulative and entirely without drama. And where there is pressure, there is warmth, not yet light. Not yet the warm amber glow you might see through a window on a winter evening. But warmth, a slow interior warmth that is the first whispered suggestion of something new. The center of the collapsing cloud grows warmer. It is still dark, it will be dark for a long time yet. But the darkness now is different from the darkness of before. The way the darkness of a room is different when you know there is a fire being laid in the grate. When you can just begin to smell the wood and the struck match. When you know that soon, in its own time, the light will come. The thing that is forming at the center has a name, though the name was given to it much later, by beings who would not exist for billions of years, standing on a small rocky world orbiting a star that has not yet been born. They would call it a protostar, from the Greek word for first, for earliest, for the thing that comes before the thing. And that is exactly what it is. The first version, the rough draft, the seed of what will eventually be a sun. The protostar is not yet burning. That word burning implies something it has not yet achieved, a threshold it has not yet crossed. What it is doing is simpler and stranger than burning. It is simply falling inward, all that gas falling toward the center, and as it falls it releases energy. The way anything falling releases energy. The way water falling over stones makes sound and foam and a kind of gentle power. The energy of all that falling material warms the protostar from within. And the protostar glows faintly, in wavelengths of light that human eyes would not be able to see. Long, slow infrared warmth radiating outward into the surrounding cloud. The cloud around it is still there, still thick and dusty, wrapping the protostar the way a quilt wraps a sleeping child. From outside, you would not be able to see it at all. The dust is too thick, too encompassing. If you could somehow find yourself drifting in that cloud, you might smell something faintly mineral, faintly cold, the way very old stone smells, the way deep caves smell, the way the air smells just before snow. You would feel no warmth. You would see no light. And yet, at the center of everything around you, something is slowly, inexorably becoming. More material falls inward, more pressure builds. More warmth accumulates, the protostar grows denser, grows hotter at its core, and the process feeds itself in the most gentle and self-sustaining of ways. Not rushing, not accelerating dramatically, simply continuing the way a river continues, the way a season continues, the way sleep continues through the deep hours of the night. And then, after all that patient time, after all those millions of years of quiet gathering and warming and pressing together, the temperature at the very center of the protostar reaches a number so large it is easier simply to say that it becomes extraordinary. The core grows hot enough, dense enough that something new becomes possible. Something that was not possible before. That could not have been possible before. That required all of this long preparation to arrive at. The hydrogen atoms at the core, which have been pressing closer and closer together under all that accumulated weight and heat, begin to do something remarkable. They begin to fuse. Fusion is a word that sounds almost too simple for what it describes. It means, at its most basic, that two things join to become one thing, and in the joining release something. In this case, what joins are the nuclei of hydrogen atoms, the tiny dense hearts of the simplest element in the universe. And what they become when they join is helium, the next simplest element, slightly heavier, slightly different, carrying within it the memory of what it was made from. And what is released in that joining is energy, warmth and light, and a kind of gentle pressure that pushes outward from the core in all directions. It is, in the most literal sense, the birth of a star. Though birth, again, is perhaps too sudden a word. There is no moment you could point to and say, there, that is the exact instant it became a star and was not before. It is more like the way dawn arrives, not in a single moment, but in a slow brightening, a gradual shift from one quality of darkness to a softness, a warmth, a growing certainty of light. The fusion begins in small pockets, spreads, stabilizes, and the energy it releases begins to push back against the inward pull of gravity that has been drawing everything together for so long. And here is the thing that makes a star, the thing that makes it last, the thing that makes it possible for there to be stars at all rather than everything simply collapsing into darkness. The outward push of the energy from fusion and the inward pull of gravity find each other. And they balance, not perfectly, not rigidly, but in the soft and flexible way that a mobile balances, adjusting gently to the smallest breath of air, always finding its equilibrium again. The star settles into itself. It finds its own steady rhythm. The dust cloud around it, warmed now from within, begins to thin and clear. The light, which has been building for so long in secret, behind all those veils of gas and dust, begins to find its way outward. Slowly, the way a lamp seen through fog gradually resolves from a smear of light into something distinct and warm. The star begins to shine. The first light it sends outward into the dark is not dramatic. It does not announce itself. It simply begins to travel, in all directions at once, at the only speed light knows, outward through the space where the cloud used to be, outward through the dark between things, a warmth and a brightness moving away from its source and toward whatever happens to be waiting in its path. If you could have been there, drifting at a safe and comfortable distance, the moment the star first became visible through its thinning veil of dust, you might have noticed something that looked almost familiar. A warm point of light, yellowish or bluish or reddish, depending on the particular mass and temperature of this particular star. Steady and quiet against the dark. Something like a candle seen through a window. Something like the first star you notice on a clear evening when the sky is still pale at the horizon and deepening to blue overhead, and you are not quite sure when you first started being able to see it. Only that it is there now, and it is warm and it is steady, and somehow it makes the dark feel less like absence and more like a kind of gentle presence. The star is young in the long life that stretches ahead of it. This moment is the very beginning, the first page of a story that will take billions of years to tell. It has settled into its balance, its rhythm, its quiet work of fusing hydrogen into helium at its core. And it will continue that work for a very long time. Not forever, nothing is forever, but for a span of time so long that the word long begins to lose its meaning. The way a word loses its meaning if you repeat it too many times. The way distance loses its meaning when the numbers become too large to hold. Around the young star, the remaining material from the original cloud is doing something of its own. Not all of it fell inward to become the star. Some of it, spinning around the star as it formed, has flattened into a disk. A slow and graceful wheel of gas and dust and ice and rock, orbiting the new sun the way cream swirls in a cup of tea, finding its own flat and circular path. In time, and time is what this story has in abundance. That disk will become other things. Planets perhaps and moons and the small cold bodies that drift in the outer dark. And perhaps on one of those planets, the conditions for something even more improbable than a star. But that is a very long way away. For now, the disk simply spins, catching the light of the star it circles, glinting faintly, unhurried. The star shines. It will shine like this for a very long time, doing its quiet work, burning steadily in the dark, neither increasing nor decreasing in any way that would be noticeable from one human lifetime to the next, or even from one civilization to the next. From where we sit, looking up on a clear night, the stars appear fixed and permanent, and in a sense they are, in the sense that anything lasting billions of years is permanent from the perspective of beings who last a handful of decades. The light reaching your eyes on any given night may have left its source before your grandparents were born, before the oldest trees on Earth were saplings, before the pyramids were stones in a quarry. It has been traveling all that time, patient as gravity, unhurried as the collapse of a cloud, and it arrives in your eye with no sense of the journey it has made. There is something restful in that thought, if you let yourself rest in it. The light was already traveling toward you before you were born, before anyone you know was born, making its way through all that quiet dark, carrying warmth and color and the simple fact of its own existence across distances that have no comfortable analogy in the world of human things. And when it arrives, it does so without ceremony, without announcement, simply becoming part of the soft, dark field of a clear night sky. Another point of warmth in the dark. Another star doing what stars do. The protostar that was a cloud, that was a gathering of dust and gas in the deep and patient dark, has become. Without hurry, without drama, without any moment you could precisely name. A sun in somewhere, perhaps. Orbiting that sun in the thin disk of material that circles it. There is a small rocky world settling into its own slow formation. Cooling and solidifying, not yet knowing what it might eventually hold. Not yet knowing anything at all. Just a world in the making, warmed by a star that is itself still young. Both of them patient, both of them in no particular hurry to become what they are slowly, gently, inevitably becoming. The star burns on, steady and warm and entirely content with its long, quiet work and the dark around it, which is never quite empty, which always holds its faint population of drifting things and distant lights, settles into the comfortable companionship of a universe that has been at this for a very long time and has learned, somewhere along the way, that the best things happen slowly. In the dark, without anyone watching, in the most unhurried and gentle way imaginable. And so it is with the long middle of a star's life. There is no fanfare to announce it. No particular morning when the star wakes and thinks, yes, today it begins in earnest. It simply continues, the way a river continues through a wide, flat valley, moving with purpose and without hurry, finding its level, settling into the work it was always going to do. Astronomers have a name for this long, steady chapter. They call it the main sequence, which sounds perhaps more official than it needs to, more clinical than the thing itself deserves. Because what the main sequence really is, when you sit with it a while, is simply a star doing what it does best. Doing it without interruption, doing it across stretches of time so vast that the word time begins to lose its familiar shape. Our own sun has been in this middle passage for roughly 4.5 billion years. And it has, by most gentle reckonings, about another 5 billion still ahead of it. Imagine the smell of something baking slowly in an oven, the warmth of it spreading through a whole house over many hours. That is closer to the feeling of it than any number could ever be. What a star does during these long, quiet billions of years is, at its heart, a kind of balancing act. Though balancing act makes it sound precarious. And it is anything but. It is more like the balance of a sleeping person breathing slowly in a dark room. The chest rising and falling in a rhythm so steady and so natural that it seems less like effort and more like the simple expression of being alive. At the center of the star, hydrogen atoms are drawn together by the star's own enormous gravity, pressed so tightly and heated so thoroughly that they fuse into helium. And in that fusing, they release energy, a soft, continuous outward pressure that pushes back against the gravity, pulling everything inward. The two forces hold each other, gravity and energy, inward and outward. And the star simply floats in that equilibrium for an almost incomprehensible span of time. The light that leaves a star during this long Middle Age has traveled a long way before it reaches any eye or instrument that might notice it. Our own sunlight, the kind that falls through a window on a slow afternoon and makes a warm rectangle on a wooden floor. Left the surface of the sun about 8 minutes before it arrived. But the energy that became that light began its journey much longer ago than that, working its way outward from the core through layer after layer of dense solar material, bouncing and scattering and being absorbed and re-emitted. A process that can take tens of thousands of years before the energy finally reaches the surface and flies free. So the light warming your face on a summer afternoon has been traveling, in one form or another, for an almost geological span of time before it found you. There is something very peaceful in that, if you let yourself feel it. Stars in their main sequence years come in a gentle range of sizes and temperatures and colors, and each has its own particular character, its own pace, its own version of the long, slow burn. The very large and very hot stars, the ones that burn a fierce blue-white, live fast by stellar standards, spending their hydrogen in what amounts to only a few million years, which sounds long but is, in the life of the universe, something like a single deep breath. The small cool stars, the red dwarfs, are so frugal with their fuel, so careful and measured in their burning, that they will persist for trillions of years, long after the universe has grown dim and quiet around them. They are the tortoises of the cosmos, steady and unhurried, burning so gently that if you could stand near one you would feel something more like the warmth of a banked fire than the blazing heat of our own midday sun. Our sun sits comfortably in the middle of this range, a yellow dwarf, which is perhaps the most modest and unassuming name in all of astronomy. It is not the largest, not the brightest, not the hottest. It is, in the very best sense, ordinary, and there is a tremendous comfort in that ordinariness, in the idea that the star which warms our world and grows our food and has been the steady companion of every living thing that has ever existed on this planet is simply a common, middling, unremarkable sort of star, doing its work without fuss, day after day, for longer than the mind can easily hold. If you could somehow travel to the surface of the sun and stand there, which of course you could not, but if you could, you would find it nothing like the smooth, glowing disk it appears from a distance. It would be a roiling, churning landscape of plasma, enormous columns of hot gas rising from below and cooler gas sinking back down. A constant slow convection that carries energy upward from the interior. These columns, called granules, are each roughly the size of a country, and they rise and fall and are replaced by new ones over the course of about 10 minutes. A kind of slow breathing of the solar surface. And across the whole of it, a steady seething light, not harsh in the way you might imagine, but warm and golden in color. The same gold that you see at the edge of a late afternoon when the sun is low and the light comes in long and level and makes everything look a little softer than it really is. Sunspots appear during this long Middle Age. Darker patches on the solar surface where intense magnetic fields have slowed the convection and allowed the surface to cool slightly. They are still extraordinarily hot by any earthly measure, but against the brighter surface around them they appear dark, like the center of a flower. They come and go in cycles of roughly 11 years, waxing and waning in number, and people have been watching them and recording them for many centuries, finding in their slow rhythm something almost meditative, a pulse, a breath, a reminder that even the most powerful things in the sky have their quiet periodicities, their seasons, their rest. The magnetic activity of a sun-like star during its main sequence years also sends out a constant gentle stream of particles. A solar wind flowing outward in all directions through the surrounding space. This wind is invisible, of course, and thin beyond any earthly comparison. But it is real, and it reaches across the whole of the solar system, filling the space between the planets with a very faint and very slow-moving breath of the sun itself. At the edges of the solar system, far out where the planets give way to the dark, this wind finally slows and mingles with the even thinner gas between the stars. And there is a boundary there, a soft and undefined place where the sun's influence gradually yields to the wider quiet of the galaxy. It has no sharp edge. It simply fades the way a sound fades when you walk away from it, until you are not quite sure whether you can still hear it or whether you are only remembering it. There is a quality to the long middle age of a star that is very much like the quality of a good and settled life. Not a life without texture or change, but a life that has found its rhythm, that knows its own nature, that does not need to announce itself. The small variations are there, the sunspots and the solar flares and the gentle 11-year cycles. But they are variations within a deep and abiding steadiness. The star is not striving toward something. It is not building toward a conclusion. It is simply being what it is, as fully and as continuously as it can, for as long as it can. Think for a moment about the light that falls on a stone in a garden, perhaps, or on a windowsill. A smooth gray stone that has been sitting in the same patch of sunlight for years. The light falls on it every clear day, warming it through the morning and into the afternoon. And the stone absorbs that warmth and holds it, and releases it slowly after the sun has moved on. The stone does not know it is being warmed. The sun does not know it is warming the stone. And yet something is happening, something real and continuous and in its own way tender. That is the main sequence. That is the long, steady middle. A warmth given and received across distances that have no good human name, over durations that have no good human feeling, and yet somehow resulting in everything that has ever been warm, everything that has ever grown toward a light. The stars nearest to us in the night sky, the ones you can pick out on a clear evening when the air is cool and the light pollution is low. Most of them are in this same long middle passage. They are burning steadily, balancing gravity and energy, sending their light outward in all directions. Some of them are very like our sun. Some are cooler and smaller. Some are larger and hotter. But they share this quality of duration, this quality of patient continuance. When you look at them, you are not seeing something in crisis or something in transition. You are seeing something in the middle of its life, settled into its nature, doing its work. There is a particular kind of night, in late summer perhaps, when the air still holds a little of the day's warmth and the sky overhead is very dark and very clear, and the stars seem closer than usual. More present, more real, on a night like that. If you lie on your back on the grass and let your eyes adjust to the dark, the stars begin to reveal themselves in layers. The bright ones first, then more and more appearing as your eyes open wider, until the sky seems full of them, crowded with them, each one a sun, each one in its long, slow middle life. burning quietly across the dark. There is no sound from them. Of course, space carries no sound. But if there were a sound, it would be something very low and very steady. Something felt more than heard. A hum beneath everything, the hum of hydrogen becoming helium in a billion patient hearts scattered across the dark. Astronomers who study stars in their main sequence years speak sometimes about stellar evolution. But it is an evolution so slow as to be, from any human perspective, essentially invisible. A star like our Sun changes over its main sequence lifetime, growing very slightly brighter and very slightly larger as the composition of its core gradually shifts. But these changes happen over billions of years, and from one human lifetime to the next, from one civilization to the next. The Sun looks and feels and behaves exactly as it always has. The light on the water this morning is the same light that fell on the water when the first fish came to the surface to breathe air, when the first flowers opened, when the first snow fell on the first mountain. The same patient star in the same long middle of its life, sending the same warmth across the same distance to the same small blue planet. There is a softness to this thought, if you let it settle in. We are not strangers to this star. We are its long companions. We and every living thing that has ever existed here. We have grown up in its light. Our biology is calibrated to its warmth. Our sleep attuned to its rising and setting. Our moods lifted and dimmed by its presence or absence in the sky. The star does not know us, of course, but we know it, in the deepest and most cellular way, in the way that the body knows warmth before the mind has any word for it. And so the long middle continues. Day after day, year after year, millennium after millennium, the star burns. The hydrogen at its core slowly gives way to helium, the way a candle slowly gives way to a pool of wax, but so slowly that on any scale of time a human life can feel. Nothing changes at all, the light comes. The warmth comes, the solar wind flows outward. The sunspots come and go in their 11-year breathing. The granules rise and fall on the solar surface, each one the size of a country, each one lasting 10 minutes, each one replaced by another exactly like it. Somewhere in a galaxy not very different from our own, a star very like our Sun is in the early part of its main sequence, just a few 100 million years into its long middle life. And around it a young planet is just beginning to cool, and something in the shallow warm water of that planet is just beginning to organize itself in ways that might, given enough time, lead somewhere interesting. The star does not know this. It simply shines. It simply burns its hydrogen into helium with the same patient continuance it has always had. And the light falls on the water. And the water is warm. And in the warmth something stirs. That is the gift of the main sequence. If a star can be said to give gifts, it is simply the gift of time. Long, unhurried, uninterrupted time, during which anything that needs to happen slowly can happen slowly, during which the water can stay warm long enough, the light can fall consistently enough, the conditions can remain stable enough for the slow and patient processes of the world to do their work. Stars in their long middle age are not doing anything dramatic. They are simply providing the conditions for everything else. holding steady, burning on, keeping the warmth alive across the dark. And as the night deepens and the fire burns low, it is enough just to know that somewhere out there, in every direction, in numbers beyond any easy counting, stars are doing exactly this. Burning steadily, holding their balance, sending their light outward into the dark with no particular urgency and no particular destination, simply because that is what they do. And they have been doing it for a very long time. And they will go on doing it for a very long time more. The universe is, in its middle distances, a warm and patient place, full of steady lights and long, slow processes, and the quiet hum of hydrogen becoming helium in a billion unhurried hearts. And we rest here in the warmth of one of them, small and grateful and very nearly asleep, cradled in the long and gentle middle of a star's life. And so we rest there a moment, held in that long middle passage, that slow and golden burning that can last for billions of years without any particular hurry at all. Stars are not impatient things. They do not rush toward what comes next. They simply continue, warming and shining and turning hydrogen into helium in their deep cores. And the universe drifts quietly around them. And everything proceeds at the pace of something that has all the time it could ever need. But even the most patient things change. In the end, not suddenly. Not with any kind of alarm. The way a late afternoon changes into evening. You look up and the light is different. Softer and more golden and somehow larger than it was before. And you cannot say exactly when the shift began. That is how it is with a star moving into the next chapter of its life. Gradually, over millions of years, the hydrogen at the very center of the star begins to run thin. Not gone, not all at once, but thinning the way a fire thins when the largest logs have mostly burned down to coals. Still warm, still glowing, but different now. Quieter at the center. The core, which has been fusing hydrogen into helium for so long, finds itself with more helium than it knows what to do with. Helium is heavier than hydrogen, and it settles slowly like fine silt drifting to the bottom of a still pond. It gathers there at the heart of the star, dense and quiet, not yet hot enough to fuse into anything new. Just resting, and the hydrogen fusion that was happening at the very center moves outward, like a slow wave into a shell surrounding that helium core, where there is still hydrogen to burn. The star goes on shining. From the outside, nothing looks very different yet. But inside, the geometry has shifted. The way a room feels different when you move the lamp from the center to a corner. The light is still there. It is simply coming from a new place. This is where something rather wonderful begins to happen. The outer layers of the star, those enormous envelopes of gas that have been sitting quietly around the core for billions of years, begin to respond to what is happening below them. The energy from that shell of burning hydrogen pushes outward with a kind of slow, steady insistence, and the outer layers, which have no particular reason to resist, simply begin to expand gently, gradually over millions and millions of years. The star grows larger, not explosively, not dramatically, more the way bread rises in a warm kitchen. You leave it for a while, and when you come back, it has simply become more than it was. Imagine, if you like, standing in a field on a clear evening and watching a single star in the sky. You could watch it for your entire lifetime and never notice any change at all. The transformation of a star into a red giant happens on timescales so vast that a human life is barely a breath within them. The star does not know it is changing. It has no knowledge of what it is becoming. It is simply following the quiet physics that have governed it since the very beginning. The same patient rules that govern everything in the universe. From the smallest grain of dust to the largest structure of gas and light that has ever existed. As the outer layers expand, something else happens, something that gives these aging stars their particular and rather beautiful name. The surface of the star, spreading outward and growing larger, cools a little, not cold. Nothing like cold. We are still talking about temperatures that would be difficult to imagine standing next to, but cooler than the fierce blue-white of a younger star, cooler even than the steady yellow of a middle-aged sun. The surface settles into a warmer, deeper color, a reddish orange, like the last light of a long summer evening. Like embers in a hearth when the fire has been burning for many hours and has reached that deep and comfortable glow. This is where the name comes from. Red giant, a star grown large and warm-colored, expanded and softened in its outer reaches, glowing with that particular amber-rose light that feels somehow like the color of something resting. There is a star not very far from us, as astronomical distances go, called Aldebaran. It sits in the constellation Taurus, and on a clear winter night in the northern hemisphere, you can find it without much trouble. A warm reddish point of light that has been noted and named and wondered at by people for thousands of years. Aldebaran is a red giant. It has expanded to something like 40 times the width of our own sun, and it glows with that deep amber warmth that marks it as a star well along in its life. Ancient navigators used it to find their way across dark water. Shepherds in old centuries watched it rise and set and used it to mark the turning of the seasons. All of that time, all of those watching eyes. And Aldebaran was simply continuing its long and unhurried expansion, changing so slowly that no human generation ever noticed any difference at all. There is another, even larger and more famous. Betelgeuse, which sits at the shoulder of Orion and glows with a distinctly reddish light that even a casual observer can notice on a clear night. Betelgeuse is enormous in a way that is genuinely difficult to hold in the mind. If you were to place it where our sun sits, its surface would extend out past the orbit of Jupiter, swallowing Mercury and Venus and Earth and Mars along the way, filling that entire inner portion of what we think of as our solar system with warm, glowing gas, and yet it sits in the night sky as a single quiet point of light. Modest looking from our distance, just one of many stars in Orion's familiar shape. The universe has a way of making even extraordinary things look ordinary from far enough away. What is happening inside a red giant? If you could somehow drift down through those vast outer layers of cooler gas, would feel quite different from the interior of a younger star. The outer regions are enormous and relatively thin, spread wide and loose, more like a very warm fog than anything solid. The light that originates deep in the core takes a long time to work its way outward through all of that expanded material, bouncing and scattering and slowly diffusing through layer after layer of gas. If you imagine the interior of a red giant as a kind of enormous, very warm library, high ceilings, soft light coming from somewhere deep within the shelves, a gentle, pervasive warmth that seems to come from everywhere and nowhere in particular. You would have something of the feeling of it. Vast and quiet and suffused with a light that has been traveling outward for a very long time. Deep at the center, that helium core is slowly changing too. As the hydrogen shell above it continues to burn, more helium rains down into the core, and the core grows denser and hotter. In some stars, eventually, the temperature at the center climbs high enough that something new becomes possible. Helium, which has been sitting there inertly for so long, finally reaches the threshold where it can begin to fuse. 3 helium nuclei can come together to form a carbon nucleus, and in doing so they release energy. Not as much energy as hydrogen fusion, but energy nonetheless, a new source of warmth and light from a new kind of fuel. The star has found in the ashes of its earlier burning something new to burn. This moment, when helium fusion begins in the core of a red giant, happens in a way that is rather gentle in the telling, even if the physics involved are quite extreme. In stars of a certain size, the helium core has become so dense by the time it reaches fusion temperature that the ignition spreads through it very quickly, in what astronomers call a helium flash. Though flash here means something that happens over minutes and hours rather than in an instant. And the energy released is absorbed by the star's own layers before it ever reaches the surface. From the outside, nothing dramatic is visible. The star simply continues, perhaps it adjusts slightly, settles a little, the outer layers pulling back in just a small amount as the new energy source stabilizes things at the center. The star finds a new equilibrium, a new balance, and carries on shining. There is something deeply reassuring about the way stars find these new equilibria. Each time the internal conditions shift, the star responds and adjusts and finds a new way to continue. It is not a struggle. It is simply physics, the same patient arithmetic of pressure and temperature and gravity working itself out over and over again. Always finding a balance, always settling into a new steady state. The universe seems to prefer balance. Left to itself over enough time, it finds a way to even things out, to smooth the extremes, to settle. For a star like our own sun, the red giant phase will last for something in the range of 1 billion years or more. 1 billion years of that expanded, amber glowing, slowly burning existence. The sun will be larger and cooler at its surface and will fill more of the sky as seen from the inner planets, bathing everything in that deep, warm, reddish light. The surfaces of the planets will be different. The temperatures changed, the whole character of the inner solar system transformed by the slow expansion of the star at its center. But it will happen so gradually that if you could somehow watch it in fast forward, compressed into a single hour, it would still look more like a slow tide coming in than anything sudden. In the outer layers of a red giant, something rather lovely is happening on a chemical level. The turbulent mixing of gases in those expanded outer regions stirs up material from deeper within the star and carries it toward the surface. Carbon and nitrogen and oxygen, elements that were forged in the nuclear processes at the core, get mixed upward through the star's layers by great slow convection currents. Enormous rolling movements of hot gas rising and cooler gas sinking. Like the gentle circulation in a pot of very slowly warming liquid. These elements make their way toward the surface and, eventually, some of them drift off into space on the stellar wind, a slow and steady outflow of gas that all stars produce, but that red giants produce in greater abundance than younger stars. The red giant is, in a sense, sharing itself with the space around it, gently exhaling the products of its long burning life into the surrounding universe. This is one of the ways that the heavier elements, the carbon and oxygen and other atoms that make up so much of the world we know, came to be spread through the galaxy. Stars lived their long lives, fused lighter elements into heavier ones in their cores, and then in their red giant phase began to release some of those heavier elements back into space, where they eventually became part of new clouds of gas and dust. And from those clouds new stars formed, and around some of those new stars, small rocky worlds coalesced from the enriched material. The carbon in every living thing on Earth was forged in the core of some ancient star and breathed out into space during a red giant phase that ended long before our sun was born. We are, in this very literal sense, made of starlight, not metaphorically, but as a straightforward matter of nuclear physics and the patient recycling of matter across billions of years. There is a comfort in that, if you let yourself sit with it. The atoms that make up your hand, your breath, the warmth you feel right now, they have been through the interior of stars. They have been part of that deep amber burning. They have drifted through the cool outer layers of a red giant and floated in the dark between the stars and eventually, through a long chain of slow events, found their way here into this moment. Into you. The universe has been working on you for a very long time. And the red giant itself, enormous and warm and slowly sharing its substance with the space around it, continues its patient existence without any awareness of all this meaning-making that small creatures on small worlds attach to it. It simply burns and expands and glows, following the same rules it always has, the same rules that everything follows, the quiet arithmetic of physics that underlies all the warmth and light in the universe. As we drift away from the red giant, pulling back to a distance where its great warm glow becomes just a soft reddish point among many points of light, it is easy to feel a kind of tenderness toward it, something that has been burning for billions of years, that has warmed the space around it for longer than the Earth has existed, that is now in the long and mellow later portion of its life, glowing a little more softly, a little more warmly, spreading its substance gently outward into the dark. There is nothing melancholy about it. It is simply a different kind of burning, slower and wider and softer than before. And the light it casts is the color of autumn afternoons and old fireplaces and the last warm hour before sleep. The universe is full of these red giants, scattered through every galaxy, glowing their amber and orange glow among the younger, bluer stars. Each one a testament to the patience of physics and the extraordinary amount of time that the universe has at its disposal. They are the elders of the stellar population, changed and expanded by long experience, burning with a different quality of light than they once did. And they will continue in this way for a very long time yet before the next slow change begins to make itself felt in their deep and quiet interiors. For now, they simply glow, warm and large and unhurried, drifting through the long dark, tending their slow fires, sending their light out in all directions toward whatever might be there to receive it. And so that light travels on, patient and unhurried, carrying with it something of the star it came from. A warmth, a color, a particular quality of brightness that is entirely its own. And in time for the quieter, more modest stars, the ones not too different in size from our own sun, that long tending of the fire begins, very gently, very gradually, to change. It does not happen quickly. Nothing in the life of a star happens quickly. It happens the way a season changes in a place where the climate is mild, not with any dramatic announcement, but with a slow softening, a gradual shift in the quality of the light, a sense that something is moving, almost imperceptibly from one state into another. Over millions of years, which in the life of a star is still a relatively brief passage of time, the star begins to swell outward. The outer layers, those great drifting envelopes of gas that have surrounded the star for so long, begin to loosen their hold. They expand very slowly, like a breath being let out after a long time of being held. Imagine standing somewhere very far away and watching this happen across an enormous span of time. The way you might watch a flower open if you could slow your own sense of time down to something approaching geological patience. The star grows larger and softer, and its color deepens, shifting from the bright, steady white or yellow it has held for billions of years towards something warmer. Something more orange, something that reminds you perhaps of late afternoon light in autumn. That particular amber quality that makes everything it touches look gentle and considered. This is what astronomers call the red giant phase. And it is, in its own way, one of the most beautiful passages in a star's long life. The star is not diminishing yet. It is, in a sense, expanding into a new way of being. The outer layers drift outward into the surrounding space, becoming thinner and more diffuse, while the core at the center continues its slow work, burning now through different fuels, finding new reactions to sustain itself. There is something almost meditative about it. The way the star adapts, finds a new equilibrium even as everything around it is slowly changing. And then, over more millions of years, those outer layers continue their outward journey. They drift away from the star like smoke rising from a fire that has burned low. Not extinguished, not gone, but transformed into something less concentrated, something more spread out and airy. The core of the star, now exposed, is very hot and very small, and it sends out a particular kind of light. A strong, clear, ultraviolet light that travels outward into those drifting shells of gas and illuminates them. This is the moment, if something that takes tens of thousands of years can be called a moment, when what we know as a planetary nebula comes into being. The name is a gentle accident of history. When astronomers first began to observe these objects through early telescopes, in the soft candlelit rooms of 18th century observatories, they noticed that some of these distant glowing things had a rounded, slightly fuzzy appearance, not entirely unlike the disk of a planet seen through a modest telescope. They were not planets, of course. They were something far more extraordinary. But the name stuck the way names often do, carrying with it a kind of affectionate imprecision, a reminder that even careful observers sometimes name things for what they first imagine them to be rather than what they are. What they actually are is something worth sitting with for a moment. A planetary nebula is a star in the act of gently releasing itself into the universe. It is the outer layers of a star. those vast envelopes of gas that have surrounded it for billions of years, now drifting outward in great expanding shells, lit from within by the hot little star at the center. The light that illuminates them causes the gas to glow, and the colors that result are among the most quietly astonishing things in the known universe. There is a nebula that astronomers sometimes call the Ring Nebula. And if you were to look at it, and people have through telescopes both modest and magnificent, in observatories and in backyard gardens on clear autumn nights, you would see something that looks almost like a smoke ring, a perfect oval of soft glowing light, pale green and blue at its edges, with a faint reddish warmth further out, and at its center the tiny bright point of the star that made it all. It hangs there in the constellation Lyra, not far from the bright star Vega, and it has been expanding outward at a gentle pace for perhaps 20,000 years. 20,000 years, and it is still only a little over a light year across. That is how vast the scale of things is out there. Or there is the Helix Nebula, which is one of the closest of these objects to our own solar system. Close enough that when you see photographs of it, you can begin to make out its texture. The way the gas is not simply a smooth glow, but has a kind of structure to it. Long filaments and streamers reaching inward toward the central star, like the petals of some enormous flower. Or perhaps like the spokes of a wheel. Or like the rays of light you sometimes see spreading outward from the sun when it sits low on the horizon and the clouds are arranged just right. The Helix Nebula glows in blues and greens and a warm amber at its outer edges. And it is wide enough that if you could somehow see it with the naked eye, it would appear larger than the full moon in our sky. It is simply too faint for our eyes to catch. But it is there, enormous and quiet, going about its slow business. Each planetary nebula is different. This is one of the things that makes them so endlessly interesting to those who study them. Not the dramatic differences of crisis or catastrophe, but the quiet individuality of each one. The way each star releases itself in its own particular way, shaped by its own history, its own rotation, the presence or absence of a companion star nearby, the particular composition of its outer layers. Some are nearly perfect spheres, glowing evenly in all directions. Some are elongated, stretched out along one axis into something more oval or even cylindrical, like a soap bubble that has been gently squeezed. Some have multiple shells, one inside another, each one a different chapter in the star's long exhalation, each one glowing in slightly different colors depending on which gases are most abundant in that particular layer. There is one sometimes called the Butterfly Nebula, which has two great lobes of gas spreading outward from a central waist. And in photographs it does indeed look something like a butterfly with its wings spread, or perhaps more like a figure 8 drawn in glowing gas. Soft blues and greens and a faint warm pink at the edges. The star at its center is one of the hottest known, burning at temperatures almost too large to hold in the mind. And yet what it has made in its slow expansion is something that looks, in photographs, almost delicate. And the Cat's Eye Nebula, which has a complexity that continues to reward study. Concentric shells nested inside one another. Bright knots and filaments, a structure that suggests the star shed its outer layers not in a single long breath, but in a series of pulses, each one sending a new ring of gas outward to join the ones before it. Looking at the cat's eye is like looking at the rings inside a very old tree, each one a record of a different period in the star's life, each one carrying information about what was happening in that deep interior during that particular passage of time. The gases themselves are things we know from closer to home. Hydrogen, of course, which is the most abundant element in the universe and the primary fuel of stars throughout their long lives. Helium, which is what hydrogen becomes after it has been through the furnace of a stellar core. Oxygen, carbon, nitrogen, elements that are, in a sense, the leftovers of a star's long burning. The ash and the smoke of billions of years of nuclear reactions carried outward now into the surrounding space. When these gases are illuminated by the ultraviolet light of the central star, different elements glow in different colors. Hydrogen tends toward reds and pinks. Oxygen, when it has been stripped of some of its electrons by that hot central light, glows in a beautiful blue-green, the color that dominates so many of the most famous nebula photographs. Nitrogen contributes its own warm tones toward the edges. So when you look at a photograph of a planetary nebula and see those colors, and they are genuinely beautiful, genuinely worth looking at slowly and with attention, you are seeing a kind of map of chemistry, a picture of which elements are where, each one announcing itself in its own particular wavelength of light. The universe, it turns out, is not shy about color. It is simply that most of its colors are spread across distances and timescales that require patience and instruments to appreciate. The central star in all of this, that small, hot, exposed core, is on its own journey. As the nebula around it expands and slowly thins out over tens of thousands of years, the star is cooling very slowly. Very gradually, it is losing the heat it accumulated over its long life. It is a white dwarf now, which is the name astronomers give to these small dense remnants of what were once ordinary stars. A white dwarf is roughly the size of the Earth, though it contains roughly the mass of the Sun. All of that material compressed into something you could, in principle, walk across in a few days if such a thing were possible. It is extraordinarily dense and extraordinarily hot at first, and it glows with a clear white light that is simply the light of something very hot slowly radiating its warmth away into the surrounding space. There is no more fuel burning in a white dwarf. The reactions that sustain the star for billions of years have ended. What remains is something more like a cooling ember. Still glowing, still warm, still sending its light outward, but no longer adding new energy to the process. Over billions more years, it will cool further, shifting from white to yellow to orange to red, until eventually, in a time span longer than the current age of the universe, it becomes something dark and cold that astronomers call a black dwarf, though no black dwarf has yet had time to form. The universe is not old enough yet for any star to have completed that final cooling. But that is very far ahead. For now, the white dwarf at the center of a planetary nebula is still bright enough to illuminate what surrounds it, still sending that clear, strong light outward into the shells of gas that were once its outer layers. And those shells are still expanding, still moving outward at speeds of perhaps 10 or 20 kilometers per second. Fast by everyday standards, but slow against the vastness of space, carrying with them the elements that the star spent its life creating, scattering them into the interstellar medium. adding them to the great slow reservoir of material that drifts between the stars. This is one of the quieter but more profound things about planetary nebulae. They are not simply beautiful objects to observe from a distance. They are the mechanism by which stars return what they have made to the universe at large. All of that carbon and oxygen and nitrogen, created in the deep interior of the star over billions of years, carried outward now in those glowing shells, eventually dispersed into the space between the stars, eventually mixed with other gas and dust, eventually, in some cases, given enough time, drawn together again by gravity into new clouds, new stars, new planetary systems. The carbon in your body was made in a star. The oxygen you breathe was made in a star. It passed through something like this, through the long, slow exhalation of a dying sun, through the glowing shells of a planetary nebula, through the long dark between the stars, before it found its way here. There is something very restful in that thought, if you let yourself sit with it. Not the urgency of it, not the drama, but simply the patience of it. The patience of the universe, going about its slow recycling, its long breathing in and breathing out. Stars forming and burning and gently releasing themselves back into the space they came from, over timescales that make any human concern feel very small and very quiet. The planetary nebula expands, the central star cools. The glowing shells grow thinner and more diffuse, until eventually they are too faint to see, dissolved back into the general glow of the galaxy. Their material dispersed and mixed and on its way to somewhere new. The nebula does not end with any kind of announcement. It simply fades the way the last light of evening fades, gradually and without drama, until you look up and notice that the sky has become fully dark and the stars are out. And you cannot quite say when the transition happened. And in that darkness, in that space where the nebula once glowed, the white dwarf continues its slow cooling. Patient and unhurried, a small warm point of light in the long dark, carrying the memory of a star that once burned for billions of years, tending its slow diminishing warmth, sending its fading light outward into the quiet of the galaxy, where other stars are still burning, still going about their long work, still holding their fires steady against the dark. And so we find ourselves drifting a little further into that quiet, settling into it the way you might settle into a warm chair at the end of a long day, letting the sounds of the house grow softer around you, letting the light in the room go golden and low. There is something restful about the galaxy when you think of it this way. All those patient fires, each one going about its own unhurried business, each one burning at its own particular pace across spans of time so long and so gentle that the word slow hardly seems adequate. We have been following the lives of stars for some time now, and we have arrived at a place that asks us to slow down even further, to breathe a little more deeply, and to consider what happens when a star has done most of what it came to do. What we are talking about is a white dwarf, and the name itself is rather lovely if you sit with it for a moment. White for the color of its lingering warmth, and dwarf for the smallness it has settled into after a long and generous life. A white dwarf is what most stars become in the end. Not all of them, but most of the ones we know. Most of the ones burning quietly in the neighborhoods of the galaxy that we call home. when a star of modest size, something like our own sun, or a little larger or a little smaller, has finished its long middle age, has expanded into that soft red giant we spoke of before, and has finally breathed out its outer layers in a slow, luminous cloud. What remains at the center is this: a small, dense, extraordinarily hot object, roughly the size of the Earth, glowing with a fierce white light that has nowhere left to go but out into the dark. Imagine holding a piece of iron that has been in a fire for a very long time. It glows, doesn't it, that deep, steady orange-white that you can feel on your face even from a distance. Now imagine something like that, but so much hotter, so much denser. A thing that has packed the mass of an entire star into a body no larger than a small world. A white dwarf, when it is newly formed, shines at temperatures that would be almost impossible to describe in everyday terms. Its surface blazes at tens of thousands of degrees, and yet it produces no new energy of its own. This is the key thing, the quiet and rather poignant truth at the heart of a white dwarf's existence. It is not burning, it is not fusing anything at its core. It is simply releasing, very slowly, the heat that it has stored over billions of years. The way a stone wall releases the warmth of a summer afternoon long after the sun has set. There is a kind of peace in that image, if you let yourself feel it. A white dwarf is not struggling. It is not reaching for anything. It is simply cooling gradually and with great patience, across timescales that make even the long lives of ordinary stars seem brief by comparison. The cooling of a white dwarf is so slow, so extraordinarily, almost incomprehensibly slow, that astronomers believe no white dwarf in the entire observable universe has yet had time to cool completely. The universe itself, at roughly 14 billion years old, is simply not old enough. Every white dwarf that has ever formed is still warm. Every one of them is still glowing, at least a little, still holding onto the last of its heat like an ember that refuses, very gently, to go entirely cold. There is something deeply soothing about that thought. Picture the galaxy as a vast, dark room and scattered through it, like the last coals in a hearth at the end of a long evening. These small warm objects cooling at their own unhurried pace. Some of them are hotter, newer, still shining with that fierce white-blue light. Others have been cooling for billions of years and have shifted in color, moving from white toward yellow, from yellow toward a faint and gentle orange. The way a fire moves through its colors as the night deepens and the wood burns lower. The composition of a white dwarf is worth pausing over, because it is rather extraordinary. Most white dwarfs are made largely of carbon and oxygen, the very elements that were forged in the star's long middle life, the products of all that patient nuclear fusion that we have been talking about across these chapters. Carbon and oxygen packed together so tightly that the material behaves in ways that feel almost dreamlike. The electrons inside a white dwarf are squeezed so close together that they push back against gravity with a force that has nothing to do with heat or pressure in any ordinary sense. It is a quantum mechanical thing, a deep property of matter itself, and it is what keeps the white dwarf from collapsing further. The star has found a kind of equilibrium, a resting state, and it will hold that state essentially forever. Just cooling, just slowly releasing its warmth into the surrounding dark. Some white dwarfs are thought to have a layer of atmosphere, thin as a whisper, composed of hydrogen or helium floating on the surface. Imagine the smell of something clean and ancient, if you could somehow breathe the air near such a place. Though of course there is no air, only the faint shimmer of a stellar atmosphere drifting above a surface that glows with its own deep internal light. The surface of a white dwarf, if you could stand near it, at a very safe distance, of course would look something like a softly luminous plane. Very still, very quiet, radiating a light that is steady and even, without the turbulence and churning of an active star. No solar flares, no great loops of plasma arcing up from the surface. Just that steady, patient glow. Over time, as the billions of years continue to accumulate, a white dwarf surface temperature falls. It moves through the color spectrum the way a day moves through its light. From the bright white of mid-morning, through the warmer yellows of afternoon, toward the deeper oranges and reds of evening. Eventually, in theory, a white dwarf that has cooled long enough would become what astronomers call a black dwarf. A dark, cold, essentially invisible object drifting through space, no longer emitting any significant light or heat. But as we noted, the universe has not yet been around long enough for this to happen. The oldest white dwarfs we know of are still faintly warm, still faintly glowing, still in the very long, very slow process of their cooling. The black dwarf remains a theoretical thing, a future that the universe has not yet had time to reach. There is something almost tender about that. The universe, for all its age, is still young enough that none of its stars have truly gone cold. Every fire that has ever burned out here in the dark is still holding a little of its warmth. It is as if the universe itself has not quite let go. White dwarfs are not lonely objects, though many of them exist in pairs, in binary systems where two stars have spent their lives in a slow gravitational dance around each other. And now one has become a white dwarf while the other continues its own life nearby. In these paired systems, the white dwarf and its companion move together in a long, quiet orbit, circling each other across the years and centuries and millennia, the way two people might walk together in comfortable silence, each keeping to their own pace, each aware of the other's presence without needing to say very much at all. The white dwarf cooling slowly, the companion star burning steadily. Two very different kinds of time existing side by side, in the same small corner of the galaxy. In some of these pairs, something rather gentle and interesting happens. The companion star, as it ages, may expand a little, and some of its outer material may drift gradually across the space between them, settling softly onto the surface of the white dwarf. This material, mostly hydrogen, accumulates in a thin layer on the white dwarf's surface over long periods of time. Eventually, if enough of it gathers, it can ignite in a slow, spreading nuclear reaction across the surface, producing a brightening that astronomers can observe from Earth. This is called a nova, and it is not a violent or catastrophic thing in the way the word might suggest. Think of it more as a gentle flaring, a brief brightening, the white dwarf becoming visible again for a little while, like a lamp turned up in a distant window. After the nova, the white dwarf settles back into its cooling, its surface a little changed, a little enriched, and the long patience of its existence continues. the material that falls onto white dwarfs, and the material that white dwarfs eventually release back into space over immense timescales, becomes part of the ongoing story of the galaxy. Carbon and oxygen, those elements forged in the star's long life, drift out into the interstellar medium, mixing with the gas and dust that floats between the stars. In time, some of that material will find its way into new clouds, new nurseries, new stars being born. The carbon in a white dwarf cooling quietly somewhere in the galaxy right now may, in some unimaginably distant future, find itself inside a new star, or a new planet, or something else entirely. Nothing is truly lost, everything is patient, and everything is moving just very, very slowly. It is worth spending a moment with the sheer number of white dwarfs that exist. Our galaxy alone is thought to contain billions of them. A vast, quiet population of cooling stellar remnants scattered through the spiral arms in the central bulge and the halo of stars that surrounds the whole structure. Most of them are invisible to the naked eye, too small and too faint to be seen without instruments. But they are there, drifting through the dark, each one a record of a star that lived and burned and completed its long work. If you could somehow see them all at once, the galaxy would look like a room full of slowly fading embers, each one at a slightly different stage of cooling, each one carrying within it the memory of a fire that once burned brightly. The nearest white dwarf to our own solar system is a companion to the brightest star in our night sky. Sirius, that steady blue-white point of light that you might have noticed on a clear winter evening. Low in the south, shining with a kind of clean, unwavering brightness, Sirius has a companion, called Sirius B, which is a white dwarf roughly the size of the Earth, but containing nearly as much mass as the Sun. It orbits Sirius at a distance that shifts slowly over the decades, and it has been cooling for a very long time, perhaps for 1 billion years or more. It is too faint to see without a telescope, but it is there, a small warm object in the dark beside its brilliant companion, going about the quiet work of cooling, unhurried and patient, as it has been doing since long before our own sun formed. There is something comforting about Sirius B, if you let yourself think about it on a quiet evening. That steady bright star you can see, Sirius itself has a companion that you cannot see, a small warm remnant of an ancient fire, cooling in the dark beside it. The two of them moving together through space. The bright one and the quiet one. The one that burns and the one that slowly cools. It feels like a kind of companionship, even across the cold distances of space. As we settle into the idea of white dwarfs cooling across billions and billions of years, it becomes easier to let go of the sense of hurry that ordinary life sometimes carries with it. These are objects that have all the time in the universe. Quite literally, they are not going anywhere. They are not becoming anything else for an extraordinarily long time. They are simply being what they are, releasing their warmth into the surrounding dark, degree by degree, century by century, in a process so gradual and so steady that it has the quality of stillness, even though it is technically always changing. The universe in this chapter of its long story is full of these quiet cooling presences. Billions of white dwarfs, each one a kind of held breath, each one a remnant of something that once burned with tremendous energy and is now finding its way toward rest. the carbon and oxygen packed inside them, the thin atmospheres drifting above their surfaces, the faint warmth they still emit. All of it is part of the same slow, patient story that the stars have been telling since the very beginning. And so we leave the white dwarfs to their cooling, to their long and unhurried drift through the dark, to the billions of years that still lie ahead of them before they reach anything like a final stillness. We leave them glowing faintly, each one a small warm point in the vast quiet of space, each one a reminder that endings, when they come, can be very gentle things, gradual and soft and full of a kind of beauty that has nothing to do with brightness or drama, but only with the slow, patient release of warmth into a universe that has time, and more time still. In the next part of our journey, we will turn our attention to a different kind of stellar ending, the ones that belong to the very largest stars, the great massive ones that have burned so fiercely and so fast, and that leave behind something altogether different when their long work is done. But that is a story for a little later. For now, let the image of the white dwarfs stay with you. Those small, warm, quietly glowing remnants, cooling forever in the dark, patient and still and full of the memory of fire. And if those small, quiet remnants carry the memory of fire within them, then somewhere else in the galaxy there are stars that never learned to be small at all. Stars that arrived into the universe already enormous, already burning with a kind of extravagance that is almost difficult to imagine, though we might try gently. Together, these are the heaviest stars, the most massive ones in their lives, compared to the long, slow patience of smaller suns, are almost startlingly brief, not brief in any way that feels rushed or anxious, but brief the way a very large candle burns quickly, giving everything it has all at once, warmly and completely before it is done. They are born the same way all stars are born, in those great drifting clouds of gas and dust that hang between the stars like curtains of fog on a cool autumn morning. Imagine the smell of something clean and cold and impossibly vast. Not quite like anything we have words for, but perhaps something like the air before rain, stretched out across distances that take light itself years and years to cross. In those clouds, gravity begins its slow, patient gathering. Particles drift toward one another. Dust grains touch, gas thickens. Very gently, the whey cream slowly swirls into a cup of warm tea, curling and folding and finding its center. For a massive star, this gathering happens on a grander scale. More material falls inward, more gas joins the slow spiral. The cloud that will become one of these enormous stars is richer, denser, more generous with itself. And so the core that forms at the heart of all that infalling material grows heavier and heavier, pressing down on itself with tremendous weight, warming as it goes, the way a woolen blanket warms simply by being folded and pressed together. By the time the nuclear fires ignite at the center of a massive star, the light that pours outward is almost beyond imagining. These stars burn tens of thousands of times brighter than our own sun. Some of them burn hundreds of thousands of times brighter. If you could stand at a comfortable distance and simply look, though of course you would want to be very far away, wrapped in the safety of imagination, the star would appear not as a point of light, but as something more like a small brilliant patch of sky, blue-white and intense, the color of the very hottest part of a flame. The color of something giving everything it has. Blue, that is the color of these stars. A deep, clear, almost electric blue-white. Because the surface temperature of the heaviest stars runs so extraordinarily high. Our own sun is a warm yellow, the color of late afternoon light on a wooden floor. But the most massive stars burn so fiercely at their surfaces that they shift all the way toward the blue end of the spectrum. The way a piece of iron heated gently glows red, then orange, then yellow, and if you could heat it further still, it would glow white and then blue. These stars have been heated further still. They sit at the very top of that long, warm scale. And because they burn so brightly, they burn through their fuel with a kind of thoroughness that smaller stars never approach. A star like our sun will spend roughly 10 billion years fusing hydrogen in its core. Slow and steady and patient, like a good fire banked for the night. But a star 20 or 30 times more massive than the sun may spend only a few million years doing the same work. A few million years that, on the scale of the universe, is something like the time it takes to finish a long, comfortable afternoon, not rushed exactly, but not lingering either. The core of a massive star is a place of extraordinary activity, though activity of a very orderly kind. The kind of busyness that has a deep rhythm to it. Like a busy kitchen where everything is moving but nothing is chaotic. Hydrogen fuses into helium, releasing energy that pushes outward against the inward pull of gravity. And the star finds its balance, its steady state, the way a river finds its level. For those few million years, the massive star simply burns, pouring light into the space around it, warming nearby clouds of gas into glowing colors, pinks and greens and soft golds, the way a lamp left on in a room tints everything around it. Those nearby clouds, lit up by the fierce blue light of massive young stars, are some of the most beautiful structures in the galaxy. We have seen them in the images that our telescopes have gathered. Those great pillars and curtains of glowing gas, soft and billowing, lit from within and without by the young stars embedded in them or hovering just nearby. Imagine the texture of light moving through fog, the way it softens and spreads and colors everything it touches. Now imagine that on a scale of light years. The fog made of hydrogen and helium and the faint traces of heavier elements. The light coming from a star so bright it can illuminate a cloud dozens of light years across. It is very gentle in its way, very patient looking from a distance. As the years accumulate, millions of them, settling one on top of another like layers of fine sediment at the bottom of a quiet lake. The hydrogen in the core of a massive star begins to run thin. The core, having done its work, shifts helium, the ash of all that hydrogen burning, begins to fuse and turn. The star adjusts itself, expands somewhat, its outer layers puffing outward like a slow breath released after a long-held pause. The surface cools a little as it spreads, shifting from blue-white towards something warmer, yellower redder, and the star grows larger, sometimes enormously larger, swelling into what we call a supergiant. A star so wide that if it sat at the center of our own solar system, its surface might extend past the orbit of Jupiter, or even further. These supergiants are extraordinary things to contemplate. They are not dense for all their size. The outer layers are actually quite thin and diffuse, more like a very deep atmosphere than a solid surface. The way the outermost layers of our own atmosphere thin gradually into space without any clear boundary. You could pass through the outer edges of a supergiant and not immediately know you had entered a star at all. Except for the warmth, the slow deepening warmth, the faint reddish light that would seem to come from everywhere at once, surrounding you completely, the way the last light of evening seems to come not from any one direction, but simply from the air itself. Inside, deeper in, the core continues its work. Helium fuses into carbon, under enough pressure and heat, fuses into heavier elements still. Oxygen, neon, silicon, each one built from the last. Each one requiring more heat and pressure than the one before. The core contracting and warming to meet each new challenge with the same steady patience it has always brought to the work. The star is, in a very real sense, building the universe's supply of heavy elements, forging in its core the atoms that will one day be part of rocks and water and the iron in living blood. All of this happening quietly, invisibly deep inside that vast glowing sphere, while the surface simply continues to shine. The outer layers of a very massive star are not entirely still during all of this. These stars breathe, in a manner of speaking. They pulse slowly, expanding and contracting over periods of years, their brightness rising and falling in long, gentle rhythms, like the slow rise and fall of a sleeping chest. And they shed material, too, in great slow winds that stream outward from the surface, carrying gas and dust away into the surrounding space. These stellar winds are not violent in any way that we would recognize. They are more like an exhalation, a continuous gentle outpouring, the way a warm stone releases heat into the cool air around it. Slowly, steadily, without drama. Over time, a massive star may shed a significant portion of its outer material this way, leaving behind a star that is somewhat smaller than it began. Its lost mass now drifting outward in an expanding shell of gas that will eventually mix with the broader clouds of the galaxy, contributing to the material from which future stars and planets will one day form. There is something deeply circular about this. Something that feels almost like a conversation the galaxy is having with itself across enormous spans of time. Material gathering, forming a star. The star returning some of that material to the galaxy. The galaxy gathering it again. When the core of a massive star has worked its way through all the fuels available to it, building heavier and heavier elements in layers like the rings of a very old tree, it reaches iron. Iron is, in a sense, the end of the road for stellar fusion. It is the element that takes more energy to fuse than it releases. And so the core, having built up a heart of iron over its long working life, simply stops. The energy source that has held the star up against its own gravity for all those millions of years is no longer there. And the core settles very quickly by stellar standards into a new and very compact form. What happens next is not something we need to dwell on in detail. It is enough to know that the outer layers of the star are released into space in a great expanding cloud, and that this cloud, moving outward through the surrounding gas and dust, carries with it all those heavy elements the star spent its life building. Carbon and oxygen and silicon and iron and dozens of other elements. All of them now free, drifting outward, cooling, mixing with the ancient hydrogen and helium of the galaxy, enriching it, making it more complex, more varied, more capable of producing. In some future age, the kinds of worlds where oceans can form and minerals can crystallize and living things can grow. The remnant left behind, the core that collapsed when the iron heart could hold no more, is something remarkable in its own quiet way. It is extraordinarily dense, a sphere perhaps 20 kilometers across, but containing more mass than our entire sun. A place where matter has been pressed together so thoroughly that the atoms themselves have merged. Electrons and protons combining into neutrons. The whole core becoming something almost unimaginably compact. We call these neutron stars, and they spin, many of them, very rapidly at first, gradually slowing over long ages, like a top that has been set spinning and slowly loses its energy to the patient air around it. Some of the heaviest stars of all leave behind something even more compact, something that curves the space around it so deeply that not even light can find its way out. But we can think of these simply as places where the star's material has gathered itself into the smallest, densest possible form, a kind of ultimate settling. The way sediment sinks to the very bottom of still water and rests there. Completely at peace, these are not frightening things. Seen from this distance in this mood, they are simply the final resting places of very large stars. Quiet and dark and in their own way complete. And the clouds of material that the star released. Those expanding shells of gas and dust. Rich with all the elements the star spent its life building. These drift outward for thousands of years, spreading slowly, thinning gradually, cooling as they go. They glow for a while, lit by the energy of their own expansion and by the remnant at their center, forming those beautiful structures we sometimes see in telescope images. Soft and colorful, like watercolors left to bleed into wet paper. All pinks and blues and greens and golds, spreading gently outward from a bright central point. In time, these clouds thin enough that they are no longer visible as distinct structures. They merge with the general material of the galaxy, adding their richness to the great slow mixture of gas and dust that drifts between the stars. And in that mixture, eventually, gravity will begin its patient gathering again. New clouds will condense, new cores will form and warm. New stars will ignite, and some of them will have planets. And some of those planets will have iron in their cores, and calcium in their rocks, and carbon in their soils. All of it forged in the hearts of stars, like the ones we have been thinking about tonight. All of it carried here across billions of years by the slow, patient work of stellar lives lived out in the dark between the galaxies. There is something deeply restful in this, if you let it settle over you. The heaviest stars, for all their brightness and their brevity, are part of the same long, slow story as all the others. The small dim stars that burn for 100 billion years. The medium stars like our sun that take their time. The white dwarfs cooling quietly in the dark. All of them are part of the galaxy's long conversation with itself. All of them contributing to the gradual enrichment of the universe. The slow building up of complexity from the simple hydrogen that filled the early cosmos. The light from a massive star, even one that burned out millions of years ago, may still be traveling toward us now. Old light, patient light, carrying across the vast distances the memory of a fire that burned briefly and brilliantly and gave everything it had to the space around it. We receive that light quietly, without urgency, the way we receive the warmth of a fire that has already settled to embers. grateful for it, not needing to understand it fully, simply letting it rest against us in the dark. And the elements in us, the iron and the carbon and the oxygen, they were made in stars like these, in cores like these, in fires that burned long before our sun existed. We carry the work of those ancient massive stars with us, quietly without thinking about it, the way we carry the warmth of the day into the cool of the evening, not noticing, simply warm. The universe is very old, and very patient and full of these long, slow stories of light and matter finding their way home. And so we arrive quietly at the end of our journey through the stars, though perhaps end is not quite the right word, because nothing in this story truly ends. It all simply continues in new shapes, in new arrangements, in new and unhurried forms. The universe does not finish things so much as it transforms them. The way a fire transforms wood into warmth and ash, and the faint, sweet smell of cedar smoke drifting through a cold evening. Nothing is lost, everything is only changed. We have spent these hours together watching stars take shape from clouds of gas and dust, watching them settle into their long, slow burning lives, watching them grow old and generous in their final years, scattering the elements they spent billions of years building back out into the dark. And now we have come to the part of the story that is perhaps the most quietly wonderful of all. The part where all of that scattered material, all of that drifting stardust, begins to find its way towards something new. Imagine, if you will, the space between stars. It is not empty, though it might seem that way at first. It is filled with the thinnest imaginable haze of atoms. Hydrogen and helium, yes, but also carbon. Oxygen, iron, calcium, all the heavier elements that were forged in stellar furnaces across billions of years, and then released into the dark when those furnaces finally cooled. This material drifts so slowly, so gently that it would take a very long time indeed to notice it moving. But it is moving, it is always, gradually finding its way somewhere. In some regions of a galaxy, this diffuse material gathers into clouds. Not clouds the way we think of them on a summer afternoon, white and soft and lit from below by reflected light. These are something altogether different, vast and dark and cool, stretching across distances so enormous that light itself takes years, sometimes centuries, to cross from one side to the other. Astronomers call them molecular clouds, because the atoms within them have had time to find each other and link together into simple molecules. Water, carbon monoxide, a quiet chemistry of the very cold and the very dark. Inside these clouds, the temperature drops lower than almost anywhere else in the universe. Not quite absolute zero, but close. Cold enough that the molecules move with extraordinary slowness, drifting in the dark like dust motes in a room where no one has walked for a very long time. There is something almost restful about it. The idea of all that matter simply waiting, cool and patient in the long quiet between one stellar generation and the next. And then gradually something begins to change. Perhaps a ripple passes through the cloud, the faint pressure wave from a distant star's final breath. Spreading outward across the galaxy like the rings a pebble makes in still water, reaching the cloud after thousands of years of travel and nudging it, ever so gently, toward a new arrangement. Or perhaps the cloud simply grows heavy enough in certain places that gravity begins to do what gravity always does. It draws things together slowly, without hurry, with the kind of patient persistence that only very large forces can sustain over very long times. Small regions within the cloud begin to condense. The material grows a little denser here, a little warmer there, and that warmth draws in more material. And the drawing in creates more warmth. And so the process continues in its slow and self-encouraging way. A protostar is beginning to form. Not yet a star, not yet burning with nuclear fire, but a gathering, a concentration, a place where matter is starting to remember that it once belonged to something bright. This process takes a very long time, hundreds of thousands of years. Sometimes longer. The protostar sits at the center of a slowly rotating disk of gas and dust. And the disk itself is a kind of nursery, a place where smaller clumps of material are beginning to coalesce. The earliest, most tentative beginnings of what might one day become planets. The whole system turns together, slowly, the way a pinwheel turns in the gentlest imaginable breeze. And the light from the young star at its center is still soft and reddish, still finding its strength. It is worth pausing here to think about what that disk contains. Mixed in among the hydrogen and helium are all those heavier atoms that came from previous generations of stars. The carbon that was cooked in a red giant's outer layers. The oxygen that was forged in a more massive star's deep interior. The iron that was built up over billions of years in stellar cores across the galaxy. All of that history, all of those long, slow lives, was present in the disk, waiting to be incorporated into whatever comes next. The new star and its eventual planets will be made, in part from the remains of stars that lived and breathed and burned long before our own sun was even a thought in the universe's mind. There is something deeply comforting in that idea. The atoms in a newly forming world are not new at all. They are ancient, well-traveled, carrying within them the record of every furnace they have passed through, every star they have helped to build. When a rocky planet eventually forms from the material in that disk, accumulating slowly over millions of years as small particles stick together and grow into pebbles and pebbles, grow into boulders and boulders, gradually sweep up more and more material. That planet is not a new thing so much as a rearrangement of very old things, settled into a new home after a very long journey. And if that planet happens to form at just the right distance from its star, close enough for liquid water, far enough not to be scorched, then something else becomes possible. The carbon atoms in the planet's surface, the hydrogen atoms in its oceans, the nitrogen atoms in its atmosphere, all of them inherited from ancient stars, may find each other in new combinations. They may begin to form molecules of increasing complexity, and those molecules may begin to do something extraordinary. They may begin to organize themselves into structures that can make copies of themselves, that can respond to their surroundings, that can, over immense stretches of time, grow and change and adapt, and eventually, after billions of years of patient experimentation, look up at the night sky and wonder where they came from. We are, all of us, made of stardust. This is not a metaphor or a poetic flourish. It is a straightforward description of chemistry and history. The calcium in your bones was made in a star. The iron in your blood was forged in a stellar core, and scattered outward in a supernova long before the sun existed. The oxygen you breathe right now passed through stellar interiors, was released into the interstellar medium, drifted for millions of years in a molecular cloud, was incorporated into the solar nebula, found its way into the early Earth, and eventually made its way into the air around you. You are, in the most literal sense, a temporary arrangement of atoms that have been traveling through the universe for billions of years, passing through star after star, world after world before arriving here. In this moment, in this particular configuration, there is no need to feel small in the face of that. If anything, it is an invitation to feel connected, to feel that you are part of a very long and continuous story, one that began in the earliest moments of the universe and will continue long after any individual chapter has closed. The atoms that make up your body today were in stars before they were in you, and they will be in other things after. In the soil, in the ocean, in the air, perhaps eventually in another star. Another world, another arrangement of matter that we cannot yet imagine. The universe, we have learned over these past hours together, operates on timescales that are almost impossible to hold in the mind all at once. A single stellar lifetime can stretch across billions of years. The time between one generation of stars and the next can encompass hundreds of millions of years of slow drifting and gradual gathering. And yet within those enormous spans of time, the same processes repeat, the same cycles turn, the same patient accumulation and eventual release continues. Generation after generation, in galaxy after galaxy, across the whole of the observable universe. Right now, as you rest, as your breathing slows and the world outside grows quiet, somewhere in the Milky Way, a molecular cloud is beginning to condense. Somewhere a protostar is gathering its first warmth. Somewhere a star that has been burning for 5 billion years is settling comfortably into the middle of its long life. Its surface warm and steady, its light falling on whatever worlds circle it in the dark. And somewhere else, a star that has lived its full span is beginning its slow and generous expansion, its outer layers drifting outward like the petals of a flower opening in slow motion, returning its accumulated wealth of elements to the space between stars, ready to be used again. All of these things are happening at once, right now in the same galaxy where our own small sun burns so reliably. So quietly, so warm, the universe is not a place of endings. It is a place of continuous transformation, of matter cycling through forms we can hardly imagine, of light finding its way through the dark over and over again in new configurations, new arrangements, new expressions of the same fundamental materials. The story of stars is, in this way, a story about abundance. Not the loud, brash abundance of things piled high, but the quiet abundance of a universe that never truly wastes anything, that takes the ashes of one fire and uses them to build the next, that takes the scattered remnants of one world and gathers them patiently into another. There is a generosity in the physics of the cosmos that is easy to overlook when you are thinking about individual events. Individual stars, individual moments, but when you step back and let the full sweep of it come into view, it is there, this deep, unhurried generosity, this willingness to take whatever is left and make something new from it. Perhaps that is the gentlest thing we can take away from all of this. That nothing in the universe is ever truly finished. That the carbon in a dying star's outer layers is not the end of that carbon story. It is simply the beginning of a new chapter, one that might unfold over millions of years before that carbon finds its way into a new star, a new world, a new life. That the light from a star that burned out billions of years ago is still traveling, still crossing the dark, still arriving at new destinations, still carrying information about the fire that made it. That even the very oldest and coldest white dwarfs, dimming so slowly that they will not fully cool for longer than the current age of the universe, are still there, still present, still part of the fabric of things. The night sky, when you look up at it on a clear evening, is not a ceiling of distant lights. It is a window into all of this, into the full complexity and patience and abundance of a universe that has been building and rebuilding itself for nearly 14 billion years. Every point of light you can see is a star with its own history, its own long, slow story of formation and burning and eventual transformation. Some of them are young, still wrapped in the remnants of the clouds that made them. Some are middle-aged and steady. Like our sun, some are old and swollen and red, beginning the slow expansion that will eventually scatter their contents outward. And some of what you see is not a single star at all, but a whole galaxy, hundreds of billions of stars, each with its own story, all of them cycling through the same patient processes, all of them part of the same enormous and unhurried conversation between matter and light and time. You are part of that conversation. You have always been part of it. The atoms that make you up have been part of it since the very beginning. Since the first stars ignited in the early universe and began the long work of building the heavier elements that would eventually make complex chemistry possible. That would eventually make you possible. There is a kind of kinship in that, a sense of belonging that requires no effort and no belief. Just the simple recognition that you are made of the same stuff as everything else. That you share your fundamental materials with the oldest stars and the youngest. With the clouds between the stars and the planets circling them. With all of it. As we come to the end of this long and quiet journey together, it seems right to simply sit for a moment with that feeling. The feeling of being part of something very large and very old and very patient. There is nothing to do with it. Nowhere to take it, it is simply there. Like the warmth of a fire. Like the smell of night air coming through an open window. Like the sound of wind moving through trees in the dark. It is the feeling of the universe going about its business all around you. Slowly, steadily, without urgency or alarm. Building and scattering and gathering and building again. In the same patient cycles it has always followed. In the same deep quiet that has always been there beneath the light and the motion and the long, slow burning of the stars. And so the story of stars is also, in the end, a story about rest. About the way that even the most energetic and luminous things eventually settle, cool and return to the quiet from which they came, only to find their way, in time, into something new. The universe breathes in and breathes out, across timescales we can barely imagine, and in the breathing there is a rhythm as steady and as soothing as anything we know. A great slow pulse moving through all of space, through all of time, through all the matter that has ever burned or drifted or gathered or glowed. You are held in that rhythm now, as you always have been, as you always will be. The stars are going about their long, slow work above you. And the atoms in your body carry the memory of all the stars that came before. And everything is, in its own way, exactly as it should be, drifting gently, settling softly, finding its way, in the fullness of time, towards something new.